All right, let's talk about something that comes up in pretty much every single system design interview, caching. Today, we're going to break it all down, drawing on some amazing insights from a former staff engineer at Meta. My goal is simple. By the end of this, you'll be able to talk about caching like a pro. Let's dive in.
So let's start with the big question. You've definitely felt this, right? Some apps are just snappy and instant, while others feel like they're crawling through mud. Why is that? Well, a huge piece of that puzzle is how they get their data. And here is the number that changes everything. 10,000 times. That's roughly how much faster it is to grab data from memory versus pulling it from a physical disk. We're talking nanoseconds versus milliseconds. Now that might not sound like a lot, but when your system is getting hammered with thousands of requests every second, that difference is absolutely massive. It's the whole ballgame.
And this is exactly where caching comes into play. You can think of a cache as a small, super fast little pantry that you keep right next to your kitchen. Instead of running to the grocery store, that's your slow database, every single time you need something, you just grab it from the pantry. It's all about making a trade-off. You introduce a little bit of complexity to your system, but in exchange, you get this huge, huge boost in speed.
So here's our game plan for today. First, we'll talk about the blueprint. Where do you even put a cache? Then we'll get into the mechanics, the different ways they can work. After that, we'll cover the rules, like how a cache decides what to keep and what to throw out, and some common problems you'll run into. And finally, we'll wrap it all up with the pitch, exactly how to talk about this stuff in an interview to really impress.
First up, the blueprint. Deciding where your cache lives is one of the first and most important decisions you'll make. And trust me, it has some pretty big implications.
Okay, so you've basically got two main options here at the application level. On one side, you have an external cache. Think of something like Redis. It's its own separate service running on its own servers, and all of your application servers can talk to it and share it. This is kind of the default choice for most systems. But on the other side, you have an in-process cache. This one lives inside your application server's memory. It's way faster because you don't have to make a network call to get to it, but the downside is that each server has its own private, separate cache. That can get tricky. You usually see this for stuff that needs to be accessed with almost zero latency, like configuration data.
But hang on, what if your users aren't all in one place? What if they're scattered all over the globe? All of a sudden, the problem isn't just memory versus disk. The new bottleneck is the actual physical distance the data has to travel. We're talking about the speed of light here.
And that brings us to content delivery networks, or CDNs. These are absolute game changers. A CDN is just a huge network of servers spread all over the world. They cache your content, like images, videos, even API responses, in locations that are physically closer to your users. So if someone in Australia requests a video, they get it from a server in Sydney, not one all the way over in Virginia. And look at that impact. You can cut latency from 350 milliseconds down to 40. For any kind of global media delivery, CDNs are not just nice to have, they're essential.
So we've figured out where we can put a cache. Now let's dig into the how. These caching architectures are really the rule books that define how your application, your cache, and your database all talk to each other.
Now, if you're going to remember one pattern, make it this one: cache aside. This is your default go-to answer in an interview. It's a lazy strategy, which works like this. First, your app asks the cache, "Hey, do you have this data?" If the cache says no, that's called a cache miss, the app then goes and gets the data from the database itself. But here's the key. Before it sends the data back to the user, it puts a copy in the cache for the next time someone asks. It's simple, it's effective, and it's what most people mean when they just say caching.
Okay, but what about when you need to write data? Well, with a write-through cache, the app writes to the cache, and the cache immediately turns around and writes that same data to the database. It waits for the database to say, "Okay, got it," before it tells the app it's done. Think of it like a debit card. The money is gone from your account instantly. It's super consistent, but it's a bit slower. Then you have write behind. Here, the app writes to the cache and gets a quick "okay." The cache then writes to the database later in the background. This is more like a credit card. The purchase is instant for you, and the bank figures out the settlement later. It feels much faster, but there's a tiny risk that if the cache crashes before it saves to the database, that data could be lost.
Feeling a little overwhelmed by all these terms like cache aside and write through? Don't be. Here's a little insider secret. Interviewers care way more that you can describe what's happening than whether you remember the fancy name for it. If you can just walk them through the flow and say, "First, I'll check the cache. If it's not there, I'll go to the database, and then I'll update the cache," you are showing them you get it. That's what really matters.
Okay, our cache is in place and we know how it works. But now things get interesting, because a cache isn't a set it and forget it kind of thing. You need rules to manage it, and you've just introduced a whole new set of potential problems to solve.
So your cache has a limited amount of space, right? It's going to fill up. When that happens, you have to kick something out to make room. That's where eviction policies come in. The most common one is LRU, or least recently used. It's simple. Whatever item has been sitting there untouched for the longest gets the boot. Then there's LFU, least frequently used, which kicks out the item that has been accessed the fewest times. This is great when a few of your items are way more popular than the rest. And finally, you have TTL, or time to live, which just sets a timer on each item. After, say, 5 minutes, it's automatically deleted. This is perfect for data that gets old or stale, like a user's session information.
You know, there's this old joke in computer science, and it's funny because it's true. The two hardest problems are naming things and cache invalidation. And while a cache is fantastic for solving your speed problem, it introduces this other really tricky challenge.
And here are 3 classic problems that interviewers love to ask about. First, the cache stampede. Imagine a super popular item expires from the cache. Suddenly, hundreds of requests all miss the cache at the same time and slam your database. Not good. You can fix this by having only one request go to the database while the others wait. Second, consistency. This is when your cache has old, stale data, but the database has been updated. The most common solution is to just delete the item from the cache whenever you write to the database. And finally, hotkeys. This happens when one single item, like a celebrity's profile, gets so popular that it overwhelms the one cache server it lives on. The simple fix here is to just copy that popular item onto a bunch of different servers to spread the load.
Whew, okay. We have covered a ton of ground. So let's bring it all together. How do you take all this knowledge and use it to sound sharp and confident in your actual system design interview?
Now, this is the golden rule. Do not, I repeat, do not just slap a cache onto your diagram without a good reason. You need to justify it. You're looking for specific triggers. Maybe you'll say, I'm noticing this system is going to be very read-heavy, and I'm worried about overwhelming the database. Or, generating this news feed for each user is computationally expensive, so it's a great candidate for caching. Or, even, to meet our requirement of a sub-100 millisecond response time, we're definitely going to need a cache. You have to identify the problem first.
So here it is, your 5-point playbook for pitching a cache in an interview. Number 1, identify the bottleneck. And if you can, use some back-of-the-envelope math to quantify it. 2, be really specific about what you're caching. What are the keys? What do the values look like? 3, choose your architecture. Cache aside is always a safe bet. Just walk through the data flow. 4, state your eviction policy and explain why you chose it. And number 5, and this is the one that shows you're a senior-level thinker, proactively talk about the downsides. Mention things like cache consistency or the risk of hotkeys. This shows you're not just thinking about the happy path, but the whole picture.
So yeah, caching might be one of those famously hard problems in computer science, but the thing is, you now have a solid framework for how to think about it, how to talk about it, and how to solve it. You're not just throwing a box on a diagram anymore. You're making a strategic decision and you understand the trade-offs. You've got this.